Welcome back, Happy Fabricators. In this video, we're going to do the Fireball Tool Fabricator Skill Tests with my $30 DIY table saw fixture table. It was definitely humbling. Let's get started. First off, the fixture table here is a build series that I've done on my channel where I bought a table saw for $30, and over several videos we have made it into a fixture table and even built a belt grinder from the remaining parts. Now, a little bit of background on this challenge here. Jason from Fireball Tool did an experiment a couple months ago where he sent out a part that he designed to multiple different weld shops to see what kind of results he got and to showcase the challenges of fabricating things without a fixture table, and specifically his fixture tables that he's designed over the last couple of years. So I thought it would be fun to do this challenge myself on my budget-friendly fixture table, and Jason himself said, and I quote,
"I'd like to see you guys try something like this." Asking somebody, can somebody just build me a box, please? Just like this.
So we're gonna try to cater to that request and see what kind of results we can get. Now, I'm not trying to knock his fixture tables in any way, shape, or form. I use them at my 9-to-5 job and I love them. They're super great tables. But I also think that there are some budget-friendly options and some techniques that can cater to good results. So I'm gonna show you how I go about doing this, and we'll see what kind of results we get. Okay, so I printed off the plans here for the challenge. He has these readily available on his website, and we're just gonna kind of go over what they are. So we've got a cut sheet here. So first off, we've got 2x2 120 wall material that we're gonna use. He's got dimensions. So one thing to notice is it's not a symmetrical square. One leg of the table here is a 1/4 inch longer or wider than the other one. So we have a 20-inch length here and 20 1/4 here. Other things I noticed is he has welds called out. So he's got bevel grooves called out for mitered corners. So he also has mitered corners called out instead of just a square end. And then he's got fillet grooves, 1/8 inch plus on both of them, called out on the fillet welds there. The other thing that we notice is we have a quantity of 2, and we have a tolerance of plus or minus a 1/16 of an inch, and that's going to apply to both the squareness and the flatness of this part. Okay, so I got my scrap material here that meets the print's specifications, and we're going to get started with this. One thing that Jason did mention is the importance of knowing the time frame that you're going to do this project in, and I totally agree. Especially if you are planning on making money on a project, the least time possible is going to be the most profitable, obviously. So I'm going to set up the stopwatch here, hopefully it works, and I'm just going to set this in the background of most of the videos so that you can kind of see where I'm at and the progress that I've made at a certain time point. I'm not going to run this video that whole length. You're just going to have to trust me that I didn't edit and cheat. The other thing that I'm going to do that's just a little bit different than the way he did it is I'm primarily a TIG welder, and I'm going to TIG weld one and MIG weld the other one just to kind of see what the difference is, see what the time difference is, and see if there is any noticeable difference in distortion or anything like that. So most of my material is clean, but especially since I'm going to TIG weld one of these, I'm going to clean up this last piece here that's got a little bit of scale on it, and I really like these strip discs. They remove the surface rust without grinding into any of the parent metal. So a quick little trick that I use to improve efficiency and accuracy whenever I'm cutting out miters is what I call the miter saw to fence difference. Now, I go over this tip in my top 5 chop saw tips. Go ahead and check that out later. But in essence, what it is, a lot of times you're measuring your distance, let's just say it's 20 inches, and you've got a line, and especially if that tube has a rolled edge on it, it is really hard to get down there and see exactly where that line translates over the edge, especially in this dark corner. So what I've learned is we chop off a quick little sample here. Then once your part is cut, you leave it in the clamp, and what you're going to do is measure from the end of your miter to the edge of the backstop. And in my case, at a 45-degree angle, this saw is 5/16 of an inch. You can see I have it written down here just so I can remember that. So what you would do is, if you wanted your piece to be exactly 20 inches, you would measure it to 19 and what would that be? That would be 11/16, minusing 5/16 out. So 19 and 11/16, and then, so let's say our mark was at 19 11/16, it's going to be perfectly in line with the edge of your backstop. So instead of having to look down at the edge, you have a straight on reference that you can make really accurate. Now, if your saw lands on an odd number like 5/16, which is kind of hard to do quick math with, another way you can do this is do the same thing, do a test cut, leave it in the clamp, and then measure from the end of your miter 1 inch back. And then you know that whatever dimension you are using, we'll run a line at 1 inch and then onto our tube. So then in this case, if we wanted our tube to be 20 inches, miter to miter, tip to tip, we would know that we could just make a mark at 19 inches. We could line it up with our mark on the fence. And then by doing that test and making that mark, you only have to subtract it by 1 inch, which is really easy. So that's just one of the little things that's helped me improve my efficiency and accuracy. Let's keep trucking on this project. Okay, so I got everything cut up and stacked over here. I stopped the timer so I can just kind of tell you about this table and the way I'm going to approach this real quick. It took me about 20 minutes-ish to get all that stuff cut out. But one thing that Jason brought up, which I believe is very important, is to know the capabilities of the equipment you have. That in application with this project is, I know that these two wings are within 10,000ths flatness across the two of them. And then if I get over onto this other wing over here, it bumps up and it's about 35 thousandths difference. So these pieces fall within the parameter of these two wings, so we're going to work off of this corner. And as you can see here, I kind of have this corner marked anyways. This is where I usually base squares off of. And what I'm going to do is, like you've seen in my other videos, these are my work stops. So I'm going to flip these guys up real quick, and we're just going to tighten them down real quick. These are just little tabs that I have on here with hardware, and this is going to allow me to have an assortment of work stops based off of a square corner. Now I also know why I have this corner marked in yellow, that this is the truest corner of the table. So when I have a long square on the corner of this table, it's less than 5 thou of rock in that square. So I know that this is the best corner of my table, so that's why I have it marked, just in case I move it around. I always know that this is the best corner to work off of. Suppose I should start my timer since I'm working again. Sorry about that. And then we're going to throw a 1 inch shim block in here, so that'll make a total of 9 inches based off of the edge of our table here. So drop our shim block in, stick our mega square in there, and then we can clamp our mega square and our shim block to the tab that's on the edge of the table. It wants to pull up on me there, so I have to put a clamp on this side of it. There's one. Okay, so we're about at the 48-minute mark, and I'm going to stop it here. Ugh. We're at 48 minutes and 19 seconds. I'm gonna write that down on the table, because this is not my 9 to 5. And it's bedtime. Okay, so next evening we're back at it here again. We're going to start our timer, and we got our one MIG welded up, and since the stop blocks are still set up here, we're going to utilize that and TIG weld that up, and then we'll assemble them together as tables. The right pieces are 20 1/4 pieces. So that's what our stops are still set up for. So if you didn't see before, I'm basing this whole thing off of the corner because I know the corner's square, and then I've got the Fireball shims here along with the Mega Square that is spacing me out that direction and holding everything true. And that worked pretty good, so we're just gonna zip through the other 7 of them, and I'll see you in a little bit. Okay, so now that we've got these all flattened out, we've got no more rocky on them here. And then if we go and stick our Mega Square on them, we're looking really true. So, liking that. Now, we can set up our table to square these out. But real quick before we do that, I gotta tell you about today's sponsor, PrimeWeld. PrimeWeld is a company that makes quality welders, plasma cutters, and fixture tables for an affordable price. I've been using PrimeWeld for a little over 3 years, well before they sponsored me, and I am super excited to have them on the team and be able to share with you another option for a budget welder that can get the job done. So if you're in the market for any of those items, go check them out, and back to the video. Get our clamps, they're hanging on the side of the table over here. We're going to utilize these side tabs again. Use the table itself to get right in the corner. Okay, so this end one here, I'm going to clamp it up against the miter gauge. And then this guy should slide right in on this side. But it's not. I put the wrong one in the wrong spot. And because I know I set that at 20 inches, I knew something was not right as soon as I stuck it in there. So, stick this guy over here. Okay, so now that I've taken some measurements, got everything pretty much squared up, I'm noticing that some of these legs are wanting to kind of lean in on me when I have it all clamped down square. And I don't have the towers like Jason has on his table to be able to build off the table and up. Now, I could potentially take one of these wings and stand it up and square it up and lock it down, and that would resemble the function of one of those towers. But what I decided I'm going to do is I'm going to take some just raw material here, got some scrap pieces, and we're going to cut these down to fit and meet the parameters of the inside dimension of these legs. So one direction we got 16 because we got 20 inches the other way, so minus 4 is 16. The other way we should have 16 and a quarter. So we're going to cut these down real quick, and we'll clamp these in between directionally, and that's going to help hold those tolerances while we weld that out. This direction is our 16, which is this guy. Stick it in between the tubes here. And then this direction, confirm my length is proper, 16 and a quarter. Stick that one in here. I'm gonna go through and I'm gonna tack all the corners first, and then we'll go through and weld as much of it out as we can with it all fixtured up. Okay, so they definitely relaxed a little bit after welding because these things are not tight. If anything, they went out a little bit, which I prefer because you can always stick a clamp on them and kind of suck them in once you're done with that. But we also need to weld the bottom side, so I'm not going to suck these in until I weld the bottom side also, because it could shrink back that other direction once we start putting weld on the opposite side of this. So we'll check that out once we get to that point. So just a quick example, this is kind of the profile that I'm looking at to grind it down to. See how I left a little flat there so that we have room to fill that in. And this is what it would look like if you left it all sharp, and that weld's just going to kind of sit on top there, so it won't be as strong and it won't look as nice. There we go. Now if you wanted to go the extra step, The other thing you can do is you could clamp, if you have enough clamps too, is you could clamp a piece of material to the side of these two tubes and the side of these two tubes, and that's going to help ensure that they're straight across or lined up, just in case you were slightly off center on your tube in relation to the miter. That's going to help line that up, but I think we're pretty good. We'll find out once we get it welded together. These are our high sides. You want to push that down. Find a longer, more robust piece of material here. It's got some junk welded to it, but it should serve the purpose. Stack some plates on top of this one and let her rip. I don't want to go too far, but I know we're going to have a little bit of rebound in the material. Let's see what that did. We are guten flat now. We've got no teeter in either direction. Feels really good. Move it over here on this part of the table. I'm going to do that to the other one. We're going to clamp it down real quick, and then we're going to see about addressing the squareness of these and see if we can't true up the relation of these legs to each other. Okay, and that did it. We got the teeter out of the MIG welding one too. It's pretty flat. There's a tiny teeter. There's a tiny teeter in it. It's a tongue twister, but we can't even fit the 32 or the 32nd Fireball shim underneath of it. So we're well within tolerance there. Now we just need to figure out which one of these guys is not quite square. Now those not being flat also could have been what was taking us out of some of our tolerance. So we'll check that out as well. Oh yeah, that's what some of it was. So let's see what we are as far as distance on these guys. This is our 16. So we're just a little bit fat on this bottom one, so we can squeeze that in and bring it a little closer. Check these ones. We should be 16 1/4 this direction. MIG welded one's right on that direction, and the TIG welded one is sucked in that direction a little bit. But I mean, overall, this one definitely needs to be addressed. We're close to an 1/8 inch out of on that one, but the rest of them are within the 1/16 inch squareness there now. So that's something else to consider, is this thing not being flat was contributing to the squareness of these legs. So if I would have messed around with squaring these legs up first, I don't know if that would have made these flatter and been vice versa, or it could have accentuated the problem. But I'm going to put this guy in the press this way, suck it in just a little bit. Go one more time. Stick the TIG welded one back up here. See how we're looking again. We are pretty close. Okay, so final results. I'm going to stop the clock here, and we're at 2 hours and 5 minutes on the first clock, and then, or actually the second clock, and then the first clock we had 48 minutes. So we're right around 2 hours and 50, almost 3 hours to get both pieces to the point that they're at right now. So as we remember, one of them was TIG welded, one of them was MIG welded. They're both done on the fixture table. Now, as far as the tolerances that we landed at, all of our dimensional tolerances are within tolerance. Most of them are even within a 32nd. On the dimensions here, our flatness on the bottom and the top. The only one that I think that we are borderline not within tolerance is the squareness of these legs, and it was definitely humbling. It was tricky. This was a really good test that Jason did. It is super tricky to keep these things square in the middle of this tube and match in the relationship to each other. So with these guys sitting on here, you can kind of see we have just a little bit over a 1/16 of an inch. Now, I could probably get that out. It would probably take me another half an hour of fiddling with them, but I think that I've kind of experimented to the point that I needed to. I believe this was just super fun and informational. I definitely learned a lot on how I would approach a job like this coming in the door, but I also shows me what the capabilities of my table is here. It shows me what tolerances that I can confidently work with and know what kind of results I can get out of it. And also, I also learned some ways to adjust it as I was going on as far as how things were going to distort and stuff. And I have some of that experience from the past anyways, but every job, you're always learning. So this was definitely a good learning experience. As far as the welds go, I wouldn't say that they are my best welds in the world. I kind of did more of a production weld with them because the whole premise of this was kind of making money, but we'll show you some of them anyways, just to show that like I was going for production quality, not necessarily super finish quality. So as you can see, it's a decent TIG weld, but it's not quite up to my normal standard that I like. I'm primarily a TIG welder, and I kind of pride myself in being fairly good at that. And then MIG welds are definitely production welds as well. They're not super uniform, but definitely within spec, and that looks like a hole on camera, but it's not. It's just some silica. But we're definitely within spec and not globular and unprofessional, I would say. I feel like we're within the parameters of that because I didn't see any finish stipulations on these drawings as far as the type of finish or the extent of finish. Only other thing I'd probably do before I sent these out is I would go on the MIG welded one, and would take my little angle grinder and I would knock off those BBs and clean up any little sharp edges so that that was good and presentable, and then I think I'd ship them out the door. So I really enjoyed this challenge and putting these things together. I want to thank Jason for all the work that he puts into his videos. I learn a lot from them, and I think they're very educational for the fabrication industry. I'm very pleased with the results that I got out of my little budget-friendly table saw table here. Like I said, if you didn't see it in the beginning, go check out my playlist. I'll leave that down in the description of building this out. And I just like to advocate for budget-friendly ways to get started in the fabrication industry. I'm not trying to discredit Jason's tables in any way, shape, or form. Like I said, I use them at my 9-to-5 job, and they are amazing tables. If you can afford them, highly recommend picking one up. But I also recommend that you need to get started. And a good way to get started is something like this that's going to be fairly flat. It's going to help you get your foot in the door, just to start building things, to just learn how metal reacts, how things are going to distort. And if you don't do it, you're not going to know. And even if somebody tells you, you don't really learn to the same extent as if you do it yourself. At least I don't. And even though I'm not affiliated with him in any sort of way, another thing I am going to recommend is some of his smaller tools, like his Mega Squares or even his shim kits. I use both these tools in this project, and they are a smaller way that you can get your foot in the door. And to increase your productivity, these shims are great for making backstops, shimming things up to get them into place. And then these squares are great for making square things when you don't have a big fixture table. That's kind of the premise of these. Like I said, I'm not affiliated with Fireball Tool in any way, shape, or form. They just make very good quality stuff. I believe they're definitely worth every penny. And I feel like there's something that would just definitely up your fabrication quality, because I know they have done that for mine. So I really hope this video brought some sort of value to you guys. I would love to see your thoughts and opinions in the comments down below on what I could do different or how you would have approached this project. I'd love to see other people do this, and I'm sure Jason would too. So once again, if you guys want to see more fabrication content, click some of the links that are going to pop up here. If you want to be notified of upcoming videos, hit that subscribe button and ring the bell. It's free to do so. And go build some, guys.